All right. Hey guys. So let's go ahead and do day 2 of section 4.5, starting with Newton's method. Now, real quick, just as a side note, today is May 9th, 2013. Yeah. Hopefully you remember from 328 last year. That's an arithmetic sequence. Just thought that was kind of funny. But anyways, this is section 4.5, okay? Newton's method. So a little shout out to Newton here today, even though he is a dog, right? I found this meme online. I thought it was pretty funny. So, props to Newton. He did a couple of good things here and there, too, besides the dog business. All right. So, Newton's method, okay? Newton's method is a method, shocking, of finding zeros or x-intercepts of points on the graph. Okay? Because again, no calculators, right? Crazy complicated functions, right? How do we find the zeros for some of these equations? Okay? So, here's what his method consisted of, okay? He starts off by picking a point somewhat near where he thinks the x-intercept would be. And so, now this example, I'm not exactly picking a point that's that close to my x-intercept, but this is for demonstration's sake. Okay? I'm going to pick this point up here, somewhere at about f of 8.5. Now, I'm not going to call it f of 8.5, but that's where it is just about, right? And so let me draw a little dashed line down here, right? Yeah, right there is where that gives me the x value, right? That's where it hits the x-axis, okay? And I'm going to call this x value x1. And so on the graph, this is the point x1 comma f of x1. Okay, so this is how you start off, right? You pick a point near where you think the x-intercept is. And you'll see as we go along, we're going to have some hints that are going to help us identify that point. Okay, now here's Newton's method. Okay, what Newton said was, and he's a tricky guy. He's very dog-like, right? He knows how to do things. If you draw in the tangent line, right, of f of x at x equals x sub 1, right, drawing in the tangent line at x sub 1, okay, here's what you're going to do, okay? Let's find the x-intercept of that point. Did I say that point? I meant that line. Let's find the x-intercept of the tangent line to x1, because that point will correlate to a point on the graph, right, which is closer to my x-intercept. And so I'm going to call this value x sub 2, and this point on my graph will be x sub 2 comma f of x sub 2. And now let's do that again. Now let's take the tangent line at x sub 2. So I have that here in green. I don't know if that's kind of hard to see, right? But now what I'm going to do is I'm going to take the x-intercept of that line, and I'm going to call that x3. Oops, sorry, there we go. And now the more and more I do this, the closer and closer I get to the actual x-intercept. Okay? So just to recap, Newton's method right here. You're going to pick a point, right, from your x-axis, right? And then you're going to find the tangent line to f of x at that point. You're going to take that tangent line, and you're going to find where that line hits the x-axis. Now that's pretty easy to do, right? You set a line, you're going to set it equal to 0, right, because the y-coordinate is 0 here. Now, you find that x-coordinate, okay, find the tangent line to the function at that x-coordinate, start the process over again. Find the x-intercept, right? Find the point on the graph, tangent line, x-intercept, find the point on the graph, tangent line, x-intercept, over and over again. And the more you do that, the closer and closer you're going to get to that x-intercept right there. Okay? So that's what we're looking for, all right? Now, we're gonna, you guys have the notes, right? You can see the little formula down here at the bottom, but I just kind of want to talk through what we're doing here, okay? So let's go back to F1, or X1, excuse me, right? I have this point X sub 1, comma, f of X sub 1, okay? So that's a point that's on the tangent line, right? Now, I'm going to write the equation of that tangent line in point slope form. So again, here's the point, right? X sub 1 comma f of X sub 1. So in point slope form, that would be y minus f of X sub 1. And that's going to equal the slope of that tangent line. Now the slope of that line is f prime of X sub 1 times x minus X sub 1. Remember, guys, this is point slope form, right? Y minus y1 equals m times x minus x1. Okay? So that's the equation of the line. And now what I'm going to do is, if I want to find the x-intercept of this line, I'm going to let y equal 0. So this is 0 minus f of X sub 1 equals f prime of X sub 1 times x minus X sub 1. And this thing is flipping out on me. There we go. And now what I'm going to do is, f of X sub 1, I know the value of that. That's from my graph. F prime of X sub 1, well, I'm going to find the value of that when I take the derivative. X sub 1 is given, right? The only thing I'm missing here is, what is the x value? Okay, so that's what I'm going to solve for. Okay, I'm going to go ahead and solve for that x value here, right? So the first thing I'm going to do is divide both sides by f prime of X sub 1. So I get negative f of X sub 1. Whoops, not x comma 1, you moron. Over f prime of X sub 1. And that's going to equal x minus X sub 1. Okay? And now let me add X sub 1 over to the other side. So this is going to be X sub 1 minus f of X sub 1 over f prime of X sub 1. Okay, and now this is going to equal, now I'm not going to call it x anymore, right? This is the x-intercept of my tangent line, which I have here in red, right? This is X sub 2. Okay, and now I'm going to start the process over again. Okay, now let me find the equation of the tangent line at X sub 2, find its x-intercept, right? And I'm going to get closer and closer to the actual x-intercept of this graph. So the equation of the tangent line at X sub 2 is going to be same thing, point slope form, y minus f of X sub 2 equals f prime of X sub 2 times x minus X sub 2. Now, what's nice here is I'm going to follow essentially the same steps as above one more time. I'm going to let y equal 0, right? Plug in y equals 0, and I'm going to solve for x again. And what I'm going to get is very similar to what I got last time. I'm going to get X sub 2 minus f of X sub 2 over f prime of X sub 2, and that's going to equal my next point closer to the x-intercept, X sub 3. Okay? So, my goal here is to keep doing this until my x values stop changing. Okay? And we're going to be doing this on the calculator, so you'll see, right, eventually at some point, the more repetitions of this process that you do, right? At some point, your x values are going to come out to be the same, and that is going to be the x-intercept of your graph, okay? Now, we're not going to write out this process every single time, okay? And so we have the general form here, okay, for Newton's method. The next guess for the x-intercept, x sub n plus 1, equals the previous guess, x sub n, minus f of x sub n over f prime of x sub n. Okay. And basically what we're going to do is we're going to take this, right, for Newton's method, this general form, we're going to apply it to whatever problem we're given, and then we're going to plug it into the calculator. So you'll see what we're doing here, okay? All right, so let's go ahead and try this now for an actual example, okay? So top of the next page, right? Use Newton's method to solve x cubed plus 2 equals 0 between -2 and 0. So I'm going to do a couple of things here, right? First of all, f of x is the given function. F prime of x is just the derivative, 3x squared, okay? Now, x cubed plus 2 between -2 and 0, right? One little strategy here is whenever you're given an interval, start in the middle. Okay, so I'm going to let my first guess be -1. Okay? So that's my first guess, -1. Okay? Now, let me try to get x sub 2, my next guess for the x-intercept. So x sub 2 is going to equal my previous guess, x sub 1, minus f of x sub 1 over f prime of x sub 1. Which is going to equal -1 minus, now, f of -1, so if I plug -1 in for f, there's that, right? -1 cubed plus 2 over f prime of -1, so 3 times -1 squared. Okay, so this is going to be -1 minus. Now, -1 cubed is -1, plus 2 is +1. -1 squared is +1 times 3 is 3. So I get -1 minus 1/3. So I get -4/3. Okay. Now, I want to keep doing this, right? I want to keep doing this until my x values stop changing. Okay? So if I do x sub 3 now and I get -4/3 again, that's going to tell me -4/3 is my x-intercept. So let's find out if that's true. Okay? So x sub 3 is going to equal x sub 2 minus f of x sub 2 over f prime of x sub 2. Okay? So, now, this is going to become quite a pain. Okay? I'm not saying it's impossible. Okay? It's definitely possible, right? But we're going to use a calculator to help us out. Okay? So let me see what we got here, right? We have -4/3 minus, now, f of -4/3, let me put this in parentheses, right, is going to be -4/3 to the third power plus 2 divided by f prime of -1 is 3 times -4/3 squared. Hit the diamond key, hit enter. Okay, so let me zoom in to show you guys what I got here. jumbo size this bad boy, right? This is exactly what I've written here to the left, right? I have negative 4/3, right? X sub 2 minus f of x sub 2. So plugging in negative 4/3 into my function, divided by f prime of x sub 2, 3 times negative 4/3 squared. And here's what I got. Negative 1.263888889. Okay, so basically I'm going to write in this whole number. Okay, now the book says about 6 decimal places. I guess we can go 6 decimal places. So negative 1.263889. Okay, there's x sub 3. Okay, now if I wanted to, right, I could just take my input right here on my calculator. Let me make this a little bit smaller. Right, I can delete out the 4/3, and I can just hit the up key and hit enter, and that'll go ahead and replace the negative 4/3 in my function with my previous answer. Whoa, what happened? Oh God, oh sweet God, my calculator disappeared. Okay, let's try that again. Well, this is going splendidly. Okay, so you could keep doing this on the calculator, okay? Now, there's a much better way though, okay? And the much better way is found by going ahead and graphing the general form from Newton's method. Okay, so on your calculator, go to y equals, and spoiler alert there for y1, okay? And so here's what we're going to type in, right? Now, x sub n plus 1 is equal to x sub n, which we're going to call just x, okay? So this is going to be x minus f of x, so in parentheses, x cubed plus 2 parentheses, divided by f prime of x. Right? This is what I'm doing each time. Right? Every time I do a step in Newton's method, this is exactly what I'm doing. Right? I just have a different x value each time. So, might as well let the calculator do that work for us, right? This is going to be x minus, right, f of x over f prime of x, and that's going to give me the next guess in Newton's method. Okay? So, I'm going to go ahead and graph this. Zoom 6, right? So that's what it should look like. And let me zoom back out here. Okay. So my next guess for x sub 4 is going to be where I plug x into my function on the calculator. So on the calculator now, I'm going to trace F3, and now I'm going to type in negative 1.263889, and it gives me negative 1.25993. Okay, so again, let me jumbo size this. Right, I plugged in x sub 3. Right? And my output is now x sub 4. So negative 1.25993 is x sub 4. Negative 1.2599, was it 33? Yeah. There's x sub 4. Okay. So let's do this again. Okay, now my input is going to be my last output, right? So negative 1.259933. Again, hit enter, and now look how close these answers are. So I know I'm getting close, right? When I input x sub 4, right, x sub 5 is extremely close to it. Negative 1.259921. So I'm getting real close. Okay? So now, let's plug my x sub 5 into this function for the input. So negative 1.259921. Go ahead and hit enter, and voila. When I input negative 1.259921, the output is itself. This is the x-intercept of the graph. Okay? When you're doing Newton's method, right, you get the same value, that's your x-intercept. Okay? Because if we go back and look at our original drawing, right, what we're doing is we're finding the x-intercept of the tangent line of the x-intercept, if that makes sense, right? If I draw the tangent line at where the x-intercept is, right, well, the x-intercept of that line is the point I use to find that line, okay? So this is what the calculator just gave us, okay? So x sub 6 is the same as x sub 5, and that is my answer. Okay? All right, let's try another one. Okay? Use Newton's method to estimate a solution. The cosine of x equals x. Now, another way of thinking about this is cosine of x minus x equals 0. And so basically, f of x is going to equal cosine of x minus x. And let me find the x-intercepts for this graph. So I'm going to use Newton's method. So f prime of x is going to be negative sine of x minus 1. And again, I have this interval right here. So I'm going to let x sub 1 equal 1. Okay, so let's find the next guess. X sub 2 is going to be x sub 1 minus f of x sub 1 over f prime of x sub 1 okay, now when you're doing these, I would like to see at least solving x sub 2 written out by hand like this, okay? And then after that, you can start going to the calculator. Okay, so this is going to be, and now, I mean, you can still do this on the calculator, right? This is going to be 1 minus, parentheses, the cosine of 1, parentheses, minus 1, close parentheses, divided by, parentheses, negative sine of 1 minus 1, close parentheses, hit the diamond key. Okay, so this is what I typed in. So, now I'm going to round off to about 6, 7 decimal place. Let's go 6. Okay, so this is 0.750364. 0.750364. That's my x sub 2. Okay, so x sub 3 is going to equal, right? I could repeat the same process here again, right? However, instead, right, let me just type in what I need to on the calculator. Okay, so on the calculator, y1, clear out what we originally had. Okay, unjumbo size this. So this is going to be x minus f of x, which is cosine of x minus x, divided by f prime of x, which is negative sine of x minus x, close parentheses, hit enter. Okay. And now let's find x sub 3. So I'm going to go to the graph. Uh-oh, did I type something in wrong? Yes, I did. Didn't I? No? Whoops, that denominator should be minus 1. My bad. Not minus x. I was wondering why that graph looked different. Whoops, 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 whoops. There we go. All better. All right. Let's go to the graph. That looks better. Still crazy, but better. And now let's trace F3. And let's type in 0.750364. Hit enter. And I get 0.73911289. 0.73911289. There's x sub 3. Okay, let's find x sub 4 by plugging in 0.739111289 back into the function there. And I get x sub 4 is 0.739085513. So I'm getting close. 0.739085513. Okay, and now let's find x sub 5. So I'm going to plug in x sub 4, 0.739085513. And what do I get? I get itself. My fifth guess, x sub 5, is the same as x sub 4. Therefore, it is my x-intercept. That is the solution to cosine of x equals x in the interval 0 to 2, obviously. Okay. Okay, let's do one more. Use Newton's method to estimate all real solutions of the equation 6x minus radical 1 plus x squared equals 0. Now, that is my f of x, right? 6x minus radical 1 plus x squared. I'll find the derivative in a second here, but the question becomes, what is x sub 1 going to be equal to? Right? I'm not given any information here. Okay? So, one thing we can do is we can go ahead and graph the function 6x minus the square root of 1 plus x squared. Okay, so let me graph that, and whoa, that looks pretty linear. Let's do that. 6x minus 1 plus x squared. Okay, I just screwed up here. Okay, now, by looking at the graph, okay, I can see that the x-intercept is very close to 0. Okay, it's right near it. It looks a little bit to the right of it, maybe, okay, but it looks really close to 0. So that's probably a good value to start with to do Newton's method, okay? Now, I could probably pick better values like 0.1 or maybe 0.2 or maybe even 1, okay? But I think 0 will be just fine. It seems like it's pretty close to 0, okay? So I'm going to let x sub 1 equals 0. Okay, now let's find the derivative. So this is going to be f prime of x equals 6 minus square root of 1 plus x squared is going to be 1 over 2 root 1 plus x squared times the derivative of x squared, which is 2x. Now these 2's will cancel out, so I get that the derivative is 6 minus x over, oops, no 2 anymore, the square root of 1 plus x squared. And so, in general form for Newton's method, right, the next guess, x sub n plus 1, is going to equal x sub n minus f of x sub n, which is 6 x sub n minus 1 plus x sub n squared, all over 6 minus x sub n over the square root of 1 plus x sub n squared. And this is what we're going to type into our calculator, unless we really want to do this one by hand. In which case, yeah, you don't be my guest. More power to you. Okay, but let's go ahead and type this guy into our calculator. Whoa, calm down, T.I. All right. Okay, so this is going to equal x minus parentheses 6x minus radical 1 plus x squared. That's my numerator, divided by parentheses 6 minus x divided by radical 1 plus x squared. Close parentheses for the radical, close parentheses for the denominator, and hit enter. And that looks about like what I got, right, where we wrote by hand. Okay. So let's go ahead and graph. Ooh. Hardly see it, but it's there. It's a little bump right there, right above the x-axis. Okay, so let's plug in my values, right? I need to find x sub 2, so I'm going to plug in 0 onto the graph here and see what the output is. And it is 0.16 repeating. That's a nice number. We could have done that by hand. You guys all told me not to. There's x sub 2. That's my second guess for the x-intercept. Let's keep going. Plug in 0.1667. Whoops, too many sevens. Okay. And for x sub 3, I get 0.16903039. 0.16903039. Let's keep going. Let's find the fourth guess. So let me plug in 0.16903039 and hit enter, and I get 1.690385. 0.16903085. There's my fourth guess. And x sub 5, let's find out what that's going to be. So put in my input, 0.16903085. Hit enter. And boom! There it is. Same input as my output. That's going to be my x-intercept. So this is going to be 0.16903085. And I am done. All right, thank you, ladies and gentlemen. I will see you mañana.